In this video we're going to look at how to find the perimeter of a sector. So before we start, we'll just have a quick review of parts of the circle. So all we really need here is for a circle with the centre O, and that's a conventional way to denote the centre. We either have the radius, which is the distance from the centre to a point on the circumference, so it's half the way across if you'd like to think of it that way, whereas the diameter goes from one side of the circle to the other but passes through the centre. So technically it's a chord that passes through the centre. So it is important that you know the difference between the diameter and the radius, and their relationship is that the diameter is twice the radius. Now, when we come to talk about the circumference of the circle, they're really asking you for the perimeter. So you have to understand that when they say circumference, they're asking for the perimeter. So that's the first thing, because if you don't understand that it's the same thing, you think that you've been asked a question you don't know how to do. So if you remember, if you're given the radius, you can use the formula 2 pi r, so 2 times pi times r, and if you're given the diameter, it's just pi times d. And remember, pi is a Greek letter, and that's just used to denote, it's 3.14. It doesn't end, and that's just a special property that a circle has, is that if you take any sized circle, if you divide the circumference by the diameter, you will always get pi, 3.14. So once you know how to find the circumference, the perimeter of a full circle, it's one more step to get the perimeter of a sector. So if we look at a sector here, the sector is the part of a circle that looks like a slice of pizza. So this is this wedge-shaped region, and that's what it looks like in relation to the whole circle. So again, if you use the pizza analogy, it's what is a slice of pizza to the whole pizza, or a slice of cake to the whole cake. Now, some people get a little bit concerned at this point where we start to introduce Greek letters. Please don't panic. This letter here is theta. It's a Greek letter. The convention is that we use Latin letters, A, B, C, to denote sides in geometry. And when we come to talk about angles, the convention is we use Greek letters. You don't have to, but that's just the convention. It is no different to using X. So what you say here is that in a full circle, you know there are 360 degrees in the revolution. You've done work on fractions. This distance, or this angular distance here, this theta, would just be, what fraction does that represent of the full circle? That's theta over 360. Now I know the notation can appear a little daunting, but bear with it and I'll show you an example. So if you use your definition of perimeter that you would have learned in primary school, that perimeter is the distance around the outside of a closed shape. So that's the important part. It's the distance around the outside. What you find is this theta over 360, you'll see that in a few other formulae that you're going to meet down the track. 2 pi r is for a full circle. This theta over 360 is telling you what fraction of the full circle you're dealing with. So this first term here just represents, it actually gives you this curved distance, this arc. Then you say, well, the perimeter is the distance to close the shape up. So why is there two lots of r? Because you've got this radius and this radius. So that's what you need to close the circle up. And that's why with these sorts of questions, it is so important that you show you're working, because a really common mistake is that people forget to add these sides. And if there's no working, the answer's wrong, and we can't see where you've gone wrong. So what I'm going to do now is go through a very simple example. So what you're looking at here is a sector with a central angle of 60 degrees and a radius of 10 centimetres. So the first thing you should do when you look at these questions is say, am I given a diameter or a radius? In this case it's a radius, and then you can just go with the formula that we have. Okay, so there's our formula. Some people say write that down as your first step. It's good practice, it helps you remember it. Your second step, as you know from algebra, is substitution, and show your substitution. This is the important step. So this angle here, theta, is 60 in this case. So you just put 60. So 60 on 360. If you simplified that as a fraction, it's 1/6. Sometimes you'll be able to simplify it, sometimes you won't. In this case, with a calculator, you can just show that line that we've just got there, and everything will be fine. This 10 is that radius, and 2 lots of 10 because we need to close it up. So at this point, you jump over to your calculator and you key in exactly what you've just written down in your book. Now to access pi, it's down the bottom here, it's in yellow, so you need to push shift before you access it, times 10 plus 2 times 10. So there's your answer. Now be careful, because the question asks you then to round to 2 decimal places. It could ask you 3, it could ask you things called significant figures, which I think some of you have seen. So always make sure you read the question and round as appropriate. So because that's 2 decimal places, we have to go to the 3rd decimal place, because that's a 1, it's less than 5, so it doesn't change anything. And perimeter is still in linear dimension, so your original question was in centimetres, your answer is in centimetres. So I hope that gives you enough to make a start on the questions, and you just adapt the questions as you need to.